Hello everybody! Today we're going to be looking at graphing an absolute value of complex numbers. So the first thing we need to understand is the complex plane. So how we graph a complex number. You're used to real numbers, right? And they live on this number line. And we'll call it the real number line. And then there's 0 in the middle, and positive numbers are to the right, and negative numbers are to the left. And you know where all those numbers are. The complex numbers, the imaginary numbers, live on the imaginary axis here. And they're up above and below 0. So positive numbers above it, negative numbers below it. So I would live up here. 1 would be over here. And then we can graph any complex number we want by saying, oh, like maybe this is, I don't know, like 4 plus 5i. I don't know. All right. And this line here that I drew, that diagonal to that point, is actually going to represent the absolute value of that number. We'll talk about that in a minute. So we can graph each of these complex numbers, okay? 6 plus 4i. So we go out 6, 1, 2, 3, 4, 5, 6, and up 4, 1, 2, 3, 4. And there we are. There's 6 plus 4i. I can do negative 3 plus 5i. So I go left 3, 1, 2, 3, and up 5, 1, 2, 3, 4, 5. Negative 3 plus 5i. I can do a regular number, right? I can just do a regular real number. 1, 2, 3, 4. And I can do an imaginary number, a pure imaginary number, right? Negative 6i. So I just count down 6. Now, these lines that I drew out to every number is going to help us a lot when we're finding the absolute value of these numbers. So the absolute value of a number is the distance that number is from 0. So if I have 6 plus 4i, which we graphed earlier, but I'll quickly regraph. The absolute value is this distance right here. That is the absolute value of 6 plus 4i. And if I want to find that distance, all I have to do is I can think of this as a right triangle, right? With a height of 4 and a length of 6. So it would be 6 squared plus 4 squared equals c squared, if we want to call it c, right? A squared plus b squared equals c squared, using Pythagorean theorem. So 36 plus 16 equals c squared, so 52 equals c squared, and 52, so c would equal root 52. I'm ignoring the negative root because we can't have a negative distance. So c would equal 2 radical 13. That is the absolute value of 6 plus 4i. Okay, let's try again. Negative 3, which we did above, right? We graphed this already. I'm just going to transfer the graph down. So if I have this complex number here, it kind of makes that right triangle, right? And it has a height of 5 and a length of 3. Its two legs are 5 and 3, so 3 squared plus 5 squared is c squared. 9 plus 25, 34. So c equals radical 34, and I can't simplify that. And when it's purely imaginary, right, I just count down 6. Well, we can literally count how far that away. That's not a diagonal line. It's just a straight vertical line, right? So it is 6. The absolute value number is 6. But you could also do 6 squared plus 0 squared equal, and then take the square root, and yeah, you'll get 6. All right. Thanks, guys, and have a good day.